The only thing that can be able to actually help you here, or what you can do, is to subscribe to the channel and like the video. If you didn't watch the first part and the second part, make sure that you actually go there before attempting questions. Okay, now we are given a block of mass 2 kg resting on a rough horizontal table. So a rough tells us that there's what frictional force is connected by a light inextensible string uh, over a frictionless pulley to another block of mass 5 kg. The 5 kg block is vertically shown as indicating the diagram below. A force of 40 Newton is applied to the block of mass 2 kg at an angle of 15 to the horizontal, causing the block to accelerate to the right at constant acceleration. Therefore, constant acceleration doesn't mean that F net is zero, only constant speed or velocity that makes F net to be zero. Therefore, the coefficient of kinetic friction between the table and the block is 0.5. Therefore, the direction of motion is to the right, meaning the direction of motion of these blocks is to the right. I hope that makes sense, guys. So before you can calculate whatever, make sure that you understand what's written on the statement. 4.1, they want us to define normal force in words. This is how you're defining the force exerted, or the force applied on an object with which is in contact and which is perpendicular to the surface. This is how you're defining it. So make sure that you understand what this definition is saying, meaning there's no normal force on a hanging object. Why? Because it is not in contact with the surface. But when the object is in contact with the surface, normal force exists. I hope it makes sense. So let's actually try to answer 4.2. They want us to draw a free body diagram showing all the forces acting on the 2 kg block. Sometimes they can say draw a labeled free body diagram showing all vertical forces. Must draw vertical forces only or horizontal forces. So read the entire question and see if they want you to draw all forces. Now the mark allocation is 5, meaning you must show what 5 arrows pointing away from the dot. Remember, free body diagram is indicated by a dot. So let me just use my ruler so that our free body diagram can be actually drawn with straight lines. Let's just adjust our ruler to 90 degrees. Okay, to 90 degrees. Yes. This is normal force. Why? Because the object is in contact with the surface. Therefore, you put the arrow. This is Fn, or this is N. Then down here we do have what a force that is vertically pointing downwards, which is Fg. But let's actually make them to be in the same okay, let's just draw Fg over here. All right, this becomes Fg, or W, which is weight. Then this force that we are having here, this is what? This is the tension, Ft, or just T. Then they told us that there is a kinetic frictional force. Now, since there is a kinetic frictional force, okay, before that, let's actually draw the force applied. Since it is pulled at an angle, make sure that you draw it as it is on your diagram. So let's try to draw it over here the way it is actually drawn on the diagram there. This becomes Fa, force applied, or just F. Therefore, let's try to remove the ruler. All right, now the mark allocation is 5 and we have 4 arrows. Then the direction of motion is to the right. This is the direction of motion, and they told us that there's kinetic frictional force. Therefore, frictional force will oppose the motion, it will go to the left. I hope it makes sense. Now these becomes what? Let's just shorten the length. Make sure that FA and FF, they do not have same length. So this becomes what? FK. So you have all the 5 marks here. This is how they're going to mark your free body diagram, and make sure that the arrowheads, they touch the horizontal line or the vertical line. You must not actually have spaces there. I hope you understand that. Now they want us to calculate the normal force acting on the 2 kg block. If you watched my videos where I was explaining Newton's laws and all the formulas, you will know that this is the formula that we're going to use. We have 3 formulas. This is the formula that you're going to use here. Because of that scenario you're having, it will be mg minus fa sine theta. If you don't understand this, go to, I think it's the second part of Newton's laws, whereby I was explaining all of this. We do have the value of m. The value of m is 2 into 9.8 minus fa we are given, minus fa, which is 40, as we are given here. 40 Newton is applied, meaning that's the force applied. So we're going to write 40 sine of an angle. The angle that we're given is what? Is 15 over here. Let me just change my color. It will be 15. Therefore, punch your calculator. Let me just use my calculator here. Do not make yourself a staring. Use your calculator and make sure that you use it correctly. So the answer is going to be 9.25 Newton. This becomes the answer of 4.3, the normal force. I hope it makes sense, guys. So if it doesn't, make sure you go to, I think it's the second part. Okay, they want us to calculate the kinetic frictional force. You can use Fk cos mu kn. We do have the value of mu k as we are given on the statement there, or in our statement we have 0.5. Therefore, we're going to multiply 0.5 with what? The value of the normal force, which is 9.25 over here, 9.25. Therefore, you can actually use your calculator. 0.5 times 9.25. Sorry, it's not 0.5. It's 0.45. 0.45, yes. Therefore, 0.45 times 9.25. So what's our answer? Is going to be 4.16 Newton. So this becomes the value of what? Of the kinetic frictional force, or Fk. I hope that makes sense. All right, I think we can actually continue to do a 5.5. But this is very important for you to know. If you didn't understand this, make sure that you watch our videos in Newton's laws. Okay, let me just erase everything. We have 4.5 here. They want us to calculate the acceleration of the 2 kg block. When you are asked to calculate acceleration or tension, you use 2 objects or 2 blocks, right? Because acceleration is for the entire system. Now let's actually talk about the F net or the 2 kg block. But before that, let me draw a free body diagram of the 5 kg block. This is Ft. Remember, it will never have Fn. Why? Because it is not in contact with the surface. I hope it makes sense. Okay. This to the F net of the 2 kg block. So you know that here on the F net part, we only substitute horizontal forces, or forces that are parallel to the direction of motion. And since you can see here that FA is pulled at an angle, meaning that we're going to have what? Components. This is going to be FAX then we're going to have FAY. The four forces that are having an effect on the Fnet side are these horizontal forces over here, FAX, FK, and FT. Therefore, I'm going to write all of them here, FAX minus FK plus FT equal to MA. Okay, let me wipe this here so that we can have enough space to do our calculation. Now we do have the value of FA, which is negative. It will be 40, therefore it will be negative X. It's cos, then you put the angle, minus FK. We do have FK that we calculated, right? The FK that we have, it was 4.16 plus FT equal to 2A, the mass and the acceleration. Therefore, let's add, or let's group the like terms and make FT the subject of the formula. I'll use my calculator here, and immediately I will actually transpose whatever answer that we're going to get on the right. It's going to be 2A plus 42.80. This is our first equation using object number 2. Therefore, let's also use 5 kg block so that we can actually have equation 2 and solve simultaneously. And now, as you can see that the 5 kg block is not horizontal, therefore we do not have horizontal forces, but it's something that you can do in order for you to use it for your calculations. So this is for 5 kg block. Now we know that here we only substitute forces that are that are horizontal or that are parallel to the direction of motion, but these ones are vertical. But all the time, this is what you must do whenever you are given this type of a question. This is what you must do. You must actually make 5 kg block as if it was horizontal to the surface or to the direction of motion. We have our FG here. Then this one over here, it will be FT, the tension force. It's like you're pulling the 5 kg to the right so that it becomes horizontal. I'm not sure if you understand that. Now the forces that are horizontal becomes minus FT plus FG equals MA. Therefore, we do not have the value of FT. We do have mg here, which is 5, and 9.8 equals 5a. Therefore, let us make ft the subject of the formula. Plus 5 times 9.8, I'm using my calculator, going to get 49 equals 5a. Therefore, minus 5a equal to, minus ft equal to 5a plus 49. Therefore, let us divide both sides by negative for ft to be positive. This is what we have, and this is our second equation. Therefore, we can equate the equations and solve simultaneously. Therefore, equation 1 equals equation 2. Or equation 1, we know that it's 2a plus 42.80 equal to minus 5a plus 49. Therefore, let's group the like terms. It's going to have 7a equal to, use your calculator. Where's this calculator now? But you can continue writing it. 49 minus 42.80. Okay, I got my calculator. Let me try to use it so fast so that we finish this question. It's going to be 6.2. Therefore, divide both sides by 7. Then acceleration of the 2 kg block or the entire system becomes 0.89 meters per second squared. So this is our answer. This is how you're solving this question. That's why on our video, the first part and the second part, it's very important that you watch those videos so that you can be able to understand this. If you didn't watch it, make sure that you do so, because it is very important for you to understand everything that I was doing here. So if you didn't understand it, make sure that you go and watch that video. Please like this one and subscribe.